It's a hard problem today. Hello everyone, February the 3rd. We got a hard one today. Well, first of all, I took a look on discussion. I took a look on the first one. I look at this, I look at like the first line, and then I think I might have a solution. Just that line itself gave me some ideas. So I'm gonna try this one more time. Still count as hint. I'm gonna try it one more time. But today we got a difficult one, so I'm not sure how long it's gonna take to solve this one. Old one, number 76. Given two string minimum window substring, given two strings of length m and n, respectively, return the minimum window substring as such that every character in T, including duplicate, is included in the window. If there is no such substring, return the empty string. The test case will be generated such that the answer is unique. Okay, so the first one, we want to find the minimum window substring of S such that every character in T, including duplicates, is included in the window, which means the size of the window is at least the same size as T. And T and M both have size of smaller or equal to 10 to the 5th. And a follow-up, could you find an algorithm that runs in OM plus N time? Probably some, substring comparing is one of those algorithms, I think. It's called KMP, right? I think it's a KMP. I am not doing KMP. What I am doing is trying to figure out and probably mn log n, something like that. Maybe some binary search type of thing. Binary search. This is binary search. Exactly, this is binary search. Right? This is binary search. Binary search with a counter. Done. Solved it. Solved it. Binary search. But OM plus N? No way. No way. Some type of substring, window size, playing. I have no idea. All right. Anyway, let's just mn log n first. Let's just get it out of the way, and maybe we think a little bit more to see if we can get this. I mean, I can probably Java this thing, right? I might be able to Java this thing. It's not that complex. At least currently, it's playing in my head. It's not very complex. It's pretty straightforward. Java, straightforward of binary search, right? So we're gonna do int low is equal to, we say t dot size a length. I'll just do -1, and int high is gonna be s dot length +1. Just make sure we are going on the right side, and then what we're gonna do is trying to find the right one. So we say while low is smaller than high, and what we're gonna do is int mid is low plus high divided by 2. Okay. Now after we do that, mid is the range, the window size, but I need to find the matching, right? We need to match the ABC. We need to match the T, the count, right? We need to match the count, so we probably need a counter. Well, I don't really need a counter. All I need is just an array, right? I need an array, and I need something. I probably need to also write a function called boolean function, private, right? Private boolean equals, right? When have an int array1 a1 and int a2 Okay, and then we just need to try to see if these two are equal. Then if a1 dot length is not equal to a2 dot length, right, return false. And then for I0i, so a1 dot length I plus plus. Okay, I would say if a1 I is not equal to a2 I, will return false. Otherwise, return true. Okay, so very straightforward function. And then what we're gonna do is, well, we need to get int t count. Okay, is equal to new int 26. Okay, and then for int I, then 0 I smaller than t dot length I plus plus. We do t count ti minus a. Oh, there's no ti. So t dot char at I minus a. Right, another plus plus. Okay. So we handle this. What's wrong with this? Written to but never read. Oh, well, we will read it. We will read it. Okay. So mid is this. Then what we need to do is, as we go through, right, we need to create current count. Okay, current count is new int 26. Okay, same as before. Then what we need to do is, as we go forward, right, as we go forward, for I0 I smaller than s dot length I plus plus. Okay, then what do? We say if I, right, the length is smaller, so I plus 1 is smaller than mid, then we simply do current count s dot char at I minus a plus plus. Right, and then we'll continue. Once t plus 1 is I plus 1 is equal to mid. Okay, is equal to mid, which is equal to the length, right? We are hitting the same length. Now what we shall do is, equal to, we'll do that if it's you know what, I think what we shall do is do this one first. Okay, I'll do this one first. Okay, I'll do this one first. Then we say if this, then just continue. Okay, we keep going. Right, if it's smaller, we'll continue. If it's equal to, then that's when we need to first check. Right, we need to first check. Once we finish checking, we remove the next. Okay, we check. How do we check? We check by ooh, I need the answer as well. Crap. Anyway, so what we're gonna check is if If current count is equals current count and t count, right? If it's equal, if these two are equal, then we say rest shall equal to s dot substring. Beginning is going to be, ending will be I. Does it include the end? Four, 8, 0, 1, 2, 3, 4, 5, 6, 7, 8. Does not include, okay? Yeah, exclusive. So the end will surely be I plus 1 because I need to include I. But the start will be interesting. The start will be I minus mid. Okay, let's say I is pointing to 0, 1, 2. I is 2. Okay, and then we'll enter 3. So I minus 3. That is not working. I minus 3 isn't. 2 minus 3 is negative 1. So it should be I minus mid plus 1. That is the starting point, right? That is the starting point. Yeah. So we'll do the substring, okay? Once we're done, we need to make the high equals mid, okay? Else means we, actually there's no else. There's no else here because we're going through the whole thing, all right? We're going through, we basically just said, if we do this, then we will break. Okay, so that's actually better. We're gonna break, right? We'll break this. We'll get a current rest, that will break it, right? That will break it. And otherwise, if it's not equal, then I need to do current count, right? Current count with s dot chart I minus mid plus 1 minus a. This one need to minus minus, right? Into minus minus. So we once we finish this for loop, then we need to. Okay, so we can actually say string current result. Okay, then we use current result, and then we use this as a sentinel as well. If current result, right? If current result is not equal to null, right? Yeah, that's the whole purpose, to not initialize it. But uninitialized value is what? Uninitialized value of string. What is this? Is that none or? Alright, I'll do null. Wait, hold on. That's not right. That is not right. This is equal to null. Right, this is null in the beginning. So if it's equal to null, which means we haven't found any, then low shall equal to mid plus 1. Otherwise, we have found something, right? Then we shall do rest equals current rest and high equals mid. So blah blah blah. Once we get to the end, I probably should start with this. Right, once we get to the end, so it will be high going down, right? And then we'll do some stuff. Then low will be something or succeeds, and low plus equal 1, right? And then it conflicts with high. Then we're, because the previous low is correct, which means we probably can return res right here. Right here. So we're gonna try. Let's try this. Oh, uppercase and lowercase. This is going to be an issue. Uppercase and lowercase. You're forcing me to use. Damn. Uppercase and lowercase. Uppercase is here from 65. So we have to, I guess 65 all the way to 122, right? 65 to 122. 122 minus 65 plus 1. So we have 58. We have 58 items. So we need to do 58 items. This should be 58. And this shall minus the bigger A. Okay, 58. This needs to be 58. And this needs to be a bigger A. And this needs to be a bigger A. Okay, let's try this. We have pretty bad. That's pretty bad. This is fine. This is also fine. So low high is fine. T count should be fine. And this is going through this. I think this is fine. Result is fine. The first one give me what? The first one give me null. Oh, I think I got it wrong. Should be equal to null. Okay, now we all get empty string. That is interesting. Not sure which part is has the issue. Boolean equals. We'll go through everything. They have to be equal for all of them to return true. So if it equals, I will get the current substring, right? I'll get the current substring for S, then I'll break. Then if it's this, then we do this, which means throughout this thing, it never gets to be the same. That's bonkers. Come on, man, that's bonkers. None of it. Enjoy. I start from 0 all the way to the end, right? As I go, I always put this in and I check if the current, if we have, if it's within, then we just continue. If it's equal to, then I'll do the current count, right? If the current count and the target count is equal, then we already found it. I set this and I will break this. Otherwise, I will remove, right? I'll remove the count of whatever I have counted so far. Now I do the next one, I do this, So what might happen is the last one. Okay, the last one. So you go, 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 go. You hit the last one. Right? That should be fine. I should get a current result. Alright, so this requires some debugging. Ugh. Which I'm gonna oblige. That's pretty simple to debug. So we don't have this. This basically just this is a string s. Basically we're gonna hold on, so it's a string s equal to string t is equal to abc. Okay, so this is going to be minimum window st. Okay. Now we're gonna debug, but before we debug, I need to put a. Let's put it here. Okay, we debug it. Oh, what happened? Line 67. Yeah, something is not right here. I actually have no idea what went wrong. Class or interface expected? I don't know. We have class. We have a class solution. Was this the reason? I mean, I can comment out. Nope. Then I have no idea why this one is complaining. Class or interface expected? I am a class. What do you think? I'm not a class? Public class. I have public class here. What do I have to say? Public class? No. I have no clue. It used to work. It used to work. Huh? I don't understand. I don't understand at all. First of all, I don't need this. have class? Maybe it should be class main. Huh. I think I might realize maybe this is a class main. Maybe we miss a class main here. There we go. That's what we're missing. We're missing a class main here. I think now we are good. Yeah, now we're good to go. There we go. All right. Okay, we are on the right track. What are we going to do? Well, very straightforward. We're here with length is what? What's mid? Mid is 8. 8 is not gonna work. So if what? If 8. All right. That says this. Counter 2, 3, 4, 5, 6, 7, 8. Going here. Are the 2's equal? They're not equal. So I'll remove the first one. So the first is A. So that shall become 0. That is correct. Right? That is correct. And then we add a new one. Don't do this. I will check if it's equal. So not equal. I is 9. 0, 1, 2, 3, 4, 5, 6, 7, 8. Anyway, 9. Now working 10. Now working 11. Now working 12. Now working 13. Now working. So low equal to mid plus 1. That is bonkers. Oh, because it contains. Dude, it's not equal. Shoot. It contains. Does that contains that? Alright, that was my fault. That was completely my fault. Okay, so it's not equals. It should be contains, right? So we shall say does A1 contains A2. Then we don't need this. Does the count of A1 contains A2? Right. So we need to do is if anytime it's a smaller, then we don't contain. Otherwise it'll be good. So now with that, we will say contains. Does the current count contains T count? Okay, so that was the reason. That was the reason. So 10K. Alright, now we're gonna give it a shot one more time. Does it contain? I got the first one right. The second one I got an empty, which is wrong. Okay, let's see what happened right here. Well, what happened is I have this is A, this is A. Okay, so we start low as 0 and high is 2. Okay, so the first one we have mid is 1, right? Okay, mid is 1, and high is 0, smaller than 1. Okay, and I add a current, and then 1 plus 1 is the 0 plus 1 is smaller than this. Mid is 1, no. So we go here. So we do contains current and T count. That should give me a true, right? I think what happens is this is 0 minus 1, so it's 0. 0 to 1. Okay. And then I'm here, this shall get up. I don't understand. I do not understand why this is not right. Zero. Mid is 1, so it's 0. Yeah, 0 to 1. I think substring is right. Contains. Contains. A contains. Oh, it's fine because A1, A2 has the same length, right? They have the same length. So just go through everything. If anytime it's smaller than, now it doesn't contain. So contain is right. It looks to me everything is perfectly right. And I have no clue why we didn't get the result that we had expected. So it contains, right? Which means it's good, right? And then high equal to mid, we try to get a bit smaller. Okay, high equal to 1. And low is, yeah, low is still 2. That will become 0. Mid is 0. Mid is 0. Ooh, mid cannot, mid is the length. Right, mid is the length, so it cannot be 0. Now high is 1, so we have 0 to 1. Right, 0 to 1. And 0 to 1. So maybe we shall say if mid is equal to 0, which means we should also break, right? Length cannot be 0. Yep. Okay, so this is binary search with sliding window. OMN log log what? S the length. S the length is M. S length is M. So this will have to go through M. And then this is N. Oh, this is M log M. Well, N plus, because this is ON. We handle the T. And this is just M. Okay, let's try this. Yep. So look at this, 2019. That was my first attempt. And I tried Java. Oh, that was when I was also doing Java. 2019. I tried many times. Next is 2021. Already I can show it the first shot. This is probably the one shot. And then here we can actually check this answer. I think it will be the right answer, the ones with the good implementation. So this is 4. Okay, I also want to check the time. The time is what I expect OM log M to have. Okay, 267, 66, that's okay. This is a Q. Wait a second. Is this O? This is O. Unmatched. It's a deck. Did I figure it out myself? OM plus N. Not even sure if this is OM plus N. I did have like is this one the one? Yeah, okay, let's just take a look. We do a counter, And we have a shrink. Enumerate letter and index. Char included is whether all the letters in T has been found in current possible solution. And we slide window. Must check before modifying CS. Huh. So I have the two counter. I have the counter for the target. Yeah. That's for sure. We have the counter for T. And we have another counter for S. And then we just go through every single one. Right? And R is the size. But R is actually left and right. So two pointers. Okay, 2 pointers. So we have a left, I have a right. Shrink. Record where all the occurrences of T will be. Okay, we record all the occurrences and their indices, and then we have a size. What? So we do sliding window to go through all the shrink, because shrink represents all the letters that's inside this count. Okay, so we just go through this, whether all the letters in T has been found in current possible solution. Check. So we check counter S, shrink R. 0 is the letter. So I have +1 is equal to okay. So basically, I think what we're doing is we're going through this shrink version. Okay. So every time we will add a current one, and we say if including that causing, are we included? Is the char included? Right? And whatever it is, we'll include. Yeah. If +1 is equal to, that's interesting. You can just do this first and then check. And then say if it's equal to, must check before modifying CS. I don't understand why. Like, why? Why do you must modify? That doesn't make any sense. It could have just plus equal 1. Because you're gonna plus equal 1 no matter what. If it's not equal to, you're gonna plus 1. If it's equal to, you're gonna plus 1. So you can plus 1 and check, see if the character is included, okay? And then what we do is character included to see if character is not included, then R move forward. That is correct. If character, we have enough, right? If we have enough, then we try to shrink it. That's why we're moving L forward. We try to shrink it. Okay, so L smaller equal to R. And then we say result is equal to What the hell is res? Shrink L1. Shrink L1. Shrink R1. So we don't even care anyone in between, just those. So shrink L1 and shrink R1. If result 1 minus result 0. Oh, that was to see if the size was current in the result. Alright. If it's larger than our use, otherwise we remain the same. And then I'll try to shrink. So we do this minus equal 1, okay. And then if it's if by doing that we're decreasing the amount that's been included, then the character included will be minus equal 1. So we go the right as much as we can, and then we shrink the left. Right, once we shrink too much, we will just decrease, but every time once we decrease the chart include it's really is a sliding window. It's a pure sliding window solution, which is it's good. Sliding window. Okay, so we can try. Yeah, let's try it again. Okay, so we can say this is the official sliding window solution that runs in OM plus n time. Okay, so sliding window, what we need is int, again, CT, right, count C, count S, new int 58, okay, int count T is new int 58. Okay, so these are counter, ladder counter for S and T. Then for int I 0 I small t dot length I plus plus. Okay, we say ct t dot char I minus a plus plus. Okay, so that's the counter. Now what we have is we're gonna have a shrinked. So basically we're gonna have a list of list of integer. Alright. List of integer, we say shrinked s equals new array list. Okay. Then we say for int I 0 I small s dot length I plus plus. Right. What we say is if s dot char I ct minus a is larger than 0. Okay. If it's larger than 0, then can I use int? Yeah, I can. Right? Then we say shrink s dot add new int of their index and character. Index and s dot char at I, right? So this is record all the letters in S that exists in T. Okay, so when we've done that, next, all right, what's next? Next, what we're gonna do is go through the shrinked S for int I0 I smaller than shrinked dot length size I plus plus. Okay, and then as we go through, every time we handle one, we the CS need to add. Okay, so we're gonna say int number of matched letters, right? Number of matched letters. Everybody in T has to be matched, so number of matched letters, right? So the first thing we do is we say cs shrink dot get I 0 with this letter minus a, okay, with plus plus, right? So we first do this and we say if cs shrinked this dot get I 0 minus a, if this thing is equal to ct shrinked s dot get I. All right, when I say char c equal to char c, so this is gonna be this, right? So what we're gonna do is we're gonna do paste it here. That is not a char, right? That's just int. Yeah, we can actually say int char. Say int char, int c, right? Int c. So the counter goes first, and this one will go if it's equal to this thing is, yeah. If these two are equal, oh my goodness, they have to be having a, and this is not T, this is C, right? So if these two are the same, right? If these two are the same, which means at the moment the counter in S regarding letter C is the same, and the number of letters C in the source in S is the same as in T. So that means we have number of match that will be plus plus, right? Now what we're gonna do is we try to shrink J. So we do need a J, right? J, sliding window. It uses a shrinked version of S that contains only the letters that also appear in T. Then we use two pointers where I is on the left, on the right, and J on the left, right? J on the left. We always expand I first, and if current window of shrinked S covers T, we move J forward, right, until the substring, right, between I and J, the substring between I and J no longer contains T, right? We also need something. That something is going to be, we need to record, right? We need to record. So we need to say int this result indices. Okay, in the index is gonna be 0 and s.length plus t.length. Yes, that's the largest, right? We want to find the smallest. What are you doing? This is not right. Okay, new int this and this. Okay, so if we imagine, and then we should say while, because we want to move the j forward. Where is j? Where is j? Int j equal to 0 as well. All right, so we need to move j forward. So while j is small equal to I, and what? And number of letters is equal to t.length, right? If it's equal to t.length, that means we still have the full coverage, right? Once we don't have the full coverage, we jump out. So we try to do this, and we need to shrink on the j side, right? We need to shrink on the j side. So the first thing we check when this one is entered, we need to update the result index, right? Because we are ending up, so j to I, right? Then we say if shrink this dot get shrink dot get I on the right hand side, so dot I, right? 1 is its index minus shrink this dot get j 1. If that is smaller than res index 1 minus res index 0, if that's the case, then res index hold on, so we need to do this. Res index 0 shall equal to shrink this dot get j1, and res index 1 shall equal to shrink dot get I 1, right? So we do that, and after we update this, now what we need to do is remove j from the CS, from the counter of S. Okay, how do we remove? We say CS of that, right? We say CS, so we can say char, no, actually int C, let's call it C, we call it CC, how about we call it CC, okay? Int CC, I mean, we can call int C because it's a different scope as the previous, shall equal to get j 0 minus a, right? Then we have to shrink it, which means CS C shall minus minus, right? Now if it's minus minus, we need to check, right? We check to say if CSC is smaller than CTC, right? If it's smaller, then we need to do a thing. Oh yeah, it says already, so let's call it CC. Okay, that's fine. CC, C, okay. So if that's the case, then number of matched letters into minus minus, because I don't have enough to cover the t. Right? After everything is done, j will plus plus. Okay? So j plus plus, and then we go up. J either larger than I, or this one is no longer equal to, right? So we come down here, we get out. So really j is smaller or equal to I, right? J is smaller or equal to I, so j come to the next one, and then when I come out, it's too much. Okay, it's too much, or I handle the j, right? So j move forward, I remove this, then the whole thing is, you know, be smaller than t, and then we'll come out. So the current, yeah, so the current is good, and then when j move forward, it's become bad. So j should stay here, right? J should stay here, and the next one I will keep moving forward, or j just move in front of I. So I think that should be fine, right? That should be fine, and then I will just keep going. I don't see any problem here. Right, j equal to 0. Number of matched letters, minus minus. Then j will plus plus, and if it's equal to, as I remove j first, right? I remove j position first, so the remaining, right? So the remaining is good, so j move forward, and then I can try it again. And if the remaining is bad, j still need to move forward, right? J still need to move forward, or j doesn't, because if the previous one's good, I already computed, so j still move forward. And then we keep going until we hit the end. Then we have these two. We have this result index, okay, result index, and what do we do? Result index. If the size, right, is within the range, then that should be the result, which means we should say if result index 1, okay, minus result index 0 plus 1 is the length is larger or equal to t dot length, and result index 1 minus result index 0 plus 1 is smaller than s dot length. If it's that, then we return s dot substring result index 0 and result index 1. I believe need to plus 1 because in here we're all inclusive, right? Otherwise we shall return just empty string. Okay, let's see if this solution works. What do you think? Index out of range. Oh, damn. I think I don't know, it's just old habit. I always put the character at the front. Okay, this one looks promising. Oh, that was bad. That was bad. Expected AA. What the hell? Input AA. T is AA, so it's the same. My output. That is interesting. Okay, so we have AA and AA. I just put this one here and then let's debug it. Okay, this one's fine, right? Shrink size 2. Shrinked. So shrinked is gonna be, yeah. Okay, F8. C is, oh, another, my bad, another should be 1. My bad, this one basically is just a typo. No, it is 0. It is 0. It's because here I forgot to change. Okay, it's okay. It's just forgot to change here. Paste this and do I. Okay, now we can try. Okay, F8, CS32, CS++. Is it equal to, it's not, and it's not. Okay, next one, I is equal to 1, and C is equal to this. Yes, this and plus plus, number of matched letters. Number of matched letters. Huh. Number of matched letters. There shall be 2 matched, right? There shall be 2 matched. Number of matched letters is 1. At this point, it should be 2. Right? It shall be 2. Like if it's equal, then number of matched should plus equal to that. But it's okay. It's not okay because I never enter this loop, which means I think here shall plus equal to CSC. Oh, actually, CTC will be a better way. Now we can try this. It shall be AA. Yeah. Okay, so what we do is we change this. All right, it should be plus equal to CTC. Okay, we run it. Did I include the last one? Yes, I did. Okay, try it again. Ooh, output, expected, input. How could output be bigger? Output can be bigger. Should be BA, ACBBA, ACBBA, right? ACBBA, okay, and then I shall be shrinking. Did you shrink? I shall shrink, right? I shrink. Shall be BBA. I remove this and J++, J is pointing here. Then shall be BBAC. BBAC, right? BBAC. BBAC is no good, so I keep going. So BBACA, right? BBACA. BBACA should be good. BBACA, that was good, so I shall start shrinking, right? I remove this BACA, right? If it's smaller, the count of CSCC. It's not smaller, so I just keep going. J++. Right? J++. And then that's weird. Because I has a front. Okay, that's interesting. Deserves some investigation. Okay, AC, BB, ACA. Okay, this is ABA. Okay, let's debug this. First come, shrink is 5. Okay. Basically it's ABBAA, right? ABBAA, yeah. Okay. Now we're gonna go F8. Okay, C32. And then 0++. No. Next one is C. Next one is B. My bad. Next one is B. B is so number matched plus equal to 1, but that's still not good. That's fine. Next one is B again. Right? B again. Next one is A again. Okay, A again. Then plus equal to that, so we 3. We match 3. Perfect match. That's good. So result is 0 and 4. 0, 1, 2, 3, 4. Yeah, that's fine. And CC is J, because J now is 0. Okay. So A shall remove 1. Okay. And then is it smaller than? Yes. So this one need to minus equal 1. Okay. So J++ to B. Okay. So J is 1. J is 1 should be B. And yeah, let's check it out. So J now is 1. I move to 3. I is 4 now. 4. So I is going to be A again. Right? It's going to be A again. So remove an A. So yeah, be A again. And it's equal. So CSC. Wait, hold on. Plus 2. Oh, shoot. Okay, hold on. I think this shall be, if it's smaller, right? Then we just plus, plus. Okay. Maybe we just plus. Because I just add 1. If it's smaller, then we just basically add one until if it's equal, we add another one. Okay, so if we run this again, okay, so basically we're going to change here, because otherwise you add again, you add a whole thing. That's adding too much. You are adding too much. Okay. Yeah, even though you know the solution, still need a lot of back and forth to get this in its correct state. There we go. That is the correct one. That is the correct one. And this, my friend, is OM plus N. Oof. Pretty good. Easy to solve with the O1 log n, but OM plus N instead of OM log n plus N, right? This is, I mean, it's just sliding window. Right? It's a quite advanced sliding window. Need to think about it first. The shrink, that is the key, right? You shrink the whole thing. That is the key. All right, this is good, and I'll end it right here. Let me just put a code in. Yeah, we don't have time to handle the other one, which is fine. And we'll see you guys tomorrow. Adios.